In this part of the lecture, we will talk about the Border Gateway Protocol, the Internet's interdomain routing protocol. In other words, how Internet service providers and content providers connect to one another on the Internet and exchange end-to-end paths so that traffic can go from point A to point B on the Internet and back. Given a basic understanding of the Border Gateway Protocol, we'll then proceed to explore how the Border Gateway Protocol can be interfered with and how sensors and other parties can attack it through a process called BGP route hijacking. Although we like to think of the Internet as a large network, it's actually a network of networks made up of more than 70,000 independently operated networks or autonomous systems. These autonomous systems, in turn, each have routers and routing protocols that run inside of each of these independently operated networks, and they connect to one another and exchange routing information over a protocol called the Border Gateway Protocol, or BGP. Sometimes those connections between the autonomous systems, or ASs, are called sessions. A network that wants to advertise reachability to some set of destinations, or IP prefixes, would use a BGP route advertisement to advertise routes over these sessions to other autonomous systems that it connects to on the Internet. A BGP route advertisement contains a lot of information, but several of the important pieces of information include the destination, or the IP prefix. You can see here two examples of University of Chicago prefixes. The next hop, which is the IP address that a router should send traffic to send traffic on its way along the next hop and route to the destination, and the AS path, or the list of ASs that the route traverses en route to the destination, encoded as a sequence of numbers, or so-called AS numbers. Having learned a BGP route advertisement, an AS can then route traffic over one of the routes it chooses to the corresponding destination. The Border Gateway Protocol, the Internet's interdomain routing protocol, essentially has no security, even today. A BGP-speaking router will believe any routes advertised by a neighboring router. And so there are different ways to interfere with Internet routing by interfering with BGP itself. We've seen an example of a complete cutoff or shutdown, as in the case of the Egypt Internet shutdown. But there are also more targeted cases that occur even by accident. But we've also seen intentional cases of BGP route hijacking, a process by which someone who doesn't own an IP prefix can advertise it in an attempt to intercept traffic to that destination. This vulnerability was first noted in 1997 when a router configuration error took down a large part of the Internet when a small Internet service provider advertised itself as the source of all of the Internet's destinations, thereby essentially sucking all of the Internet's traffic into its tiny network and causing the rest of the Internet to melt down in the process. That particular example was accidental, but we've seen other cases over the years that range from misconfiguration to incidents that certainly look more intentional. Here's a particular example from 2010 where China advertised about 50,000 IP prefixes from 170 different countries. This lasted for 20 minutes. It turns out that despite the large scale of the event, many people didn't even notice this happening. And there are a number of reasons specific to the Internet routing protocol that can explain why this didn't result in a more widespread outage or interception. But the sheer ease with which this type of route hijack took place certainly raises questions about how frequently this might happen and how easily any given country, nation state, or organization could hijack an IP prefix that it doesn't own using BGP, thereby intercepting traffic and giving that organization, nation state, or country the opportunity to either surveil that traffic or otherwise interfere with it, including blocking it or throttling it. Here's a look at that particular event in more detail. Essentially what happened was China Telecom advertised itself as the origin for more than 50,000 IP prefixes, thereby resulting in an event where traffic that ordinarily would have stayed in the United States suddenly being routed through China Telecom en route to Verizon Wireless and many other internet destinations. BGP route hijack events are in fact more frequent than you might think. Here are several examples of very high-profile so-called BGP hijack events. One, where Pakistan tried to censor YouTube, but instead accidentally advertised a small part of YouTube's AS to the entire internet, thereby resulting in a disruption of connectivity to YouTube globally. And there have been many other such events, just a few which have been cataloged here. Here's a more in-depth view of what happened when Pakistan Telecom attempted to hijack YouTube. Essentially, Pakistan Telecom told the rest of the internet that it was the source for YouTube's IP prefix, and many other autonomous systems on the internet believed that route advertisement, and instead of sending traffic to the actual YouTube servers, began sending traffic to Pakistan Telecom, resulting in a widespread outage because that particular ISP was not capable of handling that large volume of traffic or ultimately sending it to the appropriate origin or source. In summary, the Border Gateway Protocol is the Internet's interdomain routing protocol that is used to connect tens of thousands of independently operated networks. BGP is notoriously insecure and susceptible to route hijacks. These route hijacks can occur accidentally through misconfiguration, but BGP can also be exploited by censors to interfere with connectivity to specific internet sites. Route hijacks are disruptive to internet connectivity globally. They're somewhat hard to launch in a targeted fashion, as we've seen in the Pakistan Telecom case. But nonetheless, they remain a common tactic that censors use to sometimes interfere with the connectivity to specific internet sites.